Hi everyone and welcome to today's video. Today is going to be topic number 4 in this section, all the videos of differentiation. So I'll be introducing implicit functions. So today we've been dealing with explicit functions like y is equal to x squared plus 2 or something like that. So I'll be showing you how to differentiate the other kinds of implicit functions. How does that work? Let's learn something in today's video. Alright, so now next we're going to be dealing with the implicit functions. So up to the present we have dealt only with explicit functions of x. So for example, we've looked at examples like y is equal to x squared minus 5x. So here y is given as an expression in x. If however y is given implicitly by an equation such as x is equal to y power 4 minus y minus 1, we cannot express y in terms of x. So we've actually not seen such kinds of examples yet. So in these cases we can actually see that things are actually different. So an implicit function is a function that is defined by an implicit equation. So that means that the equation contains several variables, including dependent and independent ones. So in other words, it is an equation that relates one of the variables recognized as the value of the function with the others regarded as the arguments. So an implicit function is of the form f into x, comma, y. So a term like y to the power n can be differentiated by first differentiating with respect to y and then multiplying by dy dx. So that's how we're going to deal with such examples. So wherever there is a y, we're going to differentiate it with respect to y and then we're going to multiply by dy dx. So this is what we're going to have. So when you have actually a d dx of an example like this, so now when we have an x with the power and a y with the power multiplying themselves, we actually represent it this way. So now we're going to have the x being differentiated as usual, but now wherever there is a y being differentiated, we're actually going to multiply it with the dy dx, or the value that you actually get right there, and that's basically going to be it. So that's actually going to be the formula, and that's basically going to be the way we're going to be doing and working on such numbers. But this will make more sense as we work on different examples. Alright, so let's look at our first example. So now we're being told to find dy dx when x squared plus 2xy plus y squared is equal to 8. So now this is a unique example. So now we have different values. So now we have an x squared, and I believe we know how to differentiate that. Then now we have 2 into x times y. Now x times y, these are two different variables multiplying each other. So now in this case we're going to actually employ the product rule right there, and then this is y squared, and we will actually know how to differentiate that. And of course an 8 is a constant. So now we can actually see, we know that when you differentiate x squared, it's equal to 2x. That's clear. And then we can actually see that right here we're going to employ the product rule where we have the x and the y multiplying themselves. So in the product rule we have the u representing the x, so u being equal to x, so du dx is 1. Then we're going to have v representing the y, then dv dx in this case shall be equal to 1. So when you differentiate this, we're going to actually become 1. So we're going to treat it like it's a single variable, which is going to be differentiated and it's going to be equal to 1. But remember that every time you differentiate a y with respect to x, in this case we're going to multiply to it dy dx. So we're going to be left with 1 into dy dx. So now when we substitute this into the product rule, remember the product rule is u dv dx plus v du dx. So now the u value is x, and then the dv dx value is this right here. It's 1 times dy dx, plus we know that now the v value is y, which we have here, into du dx, which is equal to 1, and that's how we get this value right there. So when you look at the y value, we know that when you differentiate this with respect to x, that y squared shall become 2y. And then, as we've said, whenever you differentiate the y, in this case you're going to multiply to it a dy dx, as we've done right there. So now when we simplify this is actually what we end up having. So now let's open this bracket. So when open the brackets here and multiply the 2 within, we now have 2x into dy dx plus 2y. And then as we're going to do, we're going to separate the values that actually have a dy dx in them from the values that don't. So this is how we actually now arrange them. So now we're going to take the other values to the right hand side of the equal sign, and this is what we're left with. So now on the left hand side, we're going to factorize out the dy dx because we are looking for dy dx, so we're going to make it the subject. So dy dx shall be equal to negative 2x minus 2y over 2x plus 2y. So now at the top we can actually factorize out a 2 and it will look like that. At the bottom we can factorize out a positive 2. So at the top we factorize out a negative 2 and at the bottom we factorize out a positive 2. As you can see, this value and this cancel, and then a negative 2 over 2 is the same as negative 1, and that's actually going to be our answer. Alright, so if we move on to the next question, this is actually what we end up having. So if x squared minus 3xy plus y squared minus 2y plus 4x is equal to 0, find dy dx. So how do we solve this? So we're going to differentiate. So as you can already see that for these two values here, we're going to employ the product rule, and this is actually what we'll actually have. As you can see, the most complex part is the part right here. So we're going to let the u is actually going to present the value of x. U is going to be equal to x. Du dx shall therefore be equal to 1, and therefore v shall be represented in y, and then dv dx shall be equal to 1 dy dx. So as usual, remember that when you differentiate a y, you multiply to it the answer to dy dx, and that's actually what we've done. So substituting those values into the product rule, we now have the u being equal to x, dv dx is equal to 1 dy dx, and then we have the v value being equal to y, and then the du dx value is 1, and that's actually why we have that. So this is clear. X squared shall become 2x when you differentiate that, and then when you differentiate y squared, we know it shall become 2y, but we multiply to the answer, we're going to multiply to it dy dx. And then when we move here, we have a minus 2y. So when you differentiate this, we are left with a minus 2. And then because there is a y here, we're going to multiply to it a dy dx plus 4 being equal to 0. So we're going to simplify this, and then we're going to open the brackets. So again, we're going to separate the values that have dy dx from the values that don't. So we're going to take the values that don't have the dy dx to the opposite side of the equal sign, and that's what we end up having. So now on the other side, we're going to extract out and factorize out dy dx. Then we're going to make dy dx the subject, and then therefore dy dx shall be equal to 2x plus y plus 4 divided by 3x minus 2y plus 2, and that is the answer they wanted. Alright, so moving on to the next example. So this is what we are left with. So now we have if x cubed y power 5 plus 3x is equal to 8y cubed power plus 1, find dy dx. So now this is another good example. So now in this case, we can actually already see that now when on this pair of values here, x cubed, so you can actually see on these values here, x cubed and y power 5, we're actually going to employ the product rule because these are two different variables multiplying themselves. So now we have the u is going to be equal to x cubed. So therefore du dx shall be equal to 3x squared, and then v shall be equal to y power 5. So when you differentiate that to get dv dx, it shall be equal to 5y power 4. But now since we're differentiating and dealing with the y, we're going to multiply to it a dy dx, just like that. So now we're going to employ the product rule. So in the product rule, we can see that u is x cubed times so times du dx, and of course times dv dx, and dv dx is equal to that, plus the v value is y power 5, and then the du dx value is 3x squared, as simple as that. So as you can see, 3x, when you differentiate that, it's basically equal to 3. So on this other side, we can actually see that when we differentiate the y cubed, so this y cubed is the same as 3 into y squared, as you can actually see here, and then because it's a y, we're going to multiply to it a dy dx. So now next we're going to multiply that value to the 8 that we actually have there. So of course that will actually be equal to 24y squared, and then the 1 is actually going to become 0 because that is a constant. So therefore this is what we end up having. So now we end up with x cubed 5y power 4 dy dx plus 3x squared y power 5 plus 3 equal to 24y squared dy dx. So going to collect like terms, so the values that have dy dx go together and the values that don't also go together. So factorize out dy dx and then make it the subject. So dy dx shall be equal to 3x squared y power 5 plus 3 divided by 24y squared minus 5x cubed y power 4, and that is the answer they wanted. Alright, so moving on to the next question. Now this is different and this is unique. So we have a ln xy being equal to 4x squared. So now basically, to understand what ln means, I encourage you to watch the section that actually has exponential and natural logarithms to just have a better understanding of it, but I'll explain it for you in this case. So I have a ln xy being equal to 4x squared. So now this is a unique example. So now whenever we have a ln and we have two different values multiplying themselves like that, let's first deal with that section. Let's first deal with ln xy. So now in this case, we're going to let u represent ln xy as the whole, then we're also going to let the t represent x times y. So basically this is an example of a composite function. So this value here is composite. Okay, so we're going to employ the chain rule, but before we're going to employ the chain rule, we're going to let u represent the value as a whole, then we're going to let t represent the values right here to represent x times y in that case. So now to find dt dx, we're going to employ the product rule. So a product rule where we have x being u and y being v. So when we employ the product rule, we will end up having x times dy dx plus y times 1, as we actually have there. And basically what happened in that case, it's because we had let the u to be equal to x and we had let v to be equal to y. So du dx shall be equal to 1, dv dx shall be equal to 1, because when we differentiate this we have 1, but because it's a y, we're going to multiply to it dy dx. Then we substitute all those back into our product rule. Our u is in the product rule, we have x times dy dx plus y times 1. So dt dx shall be equal to x dy dx plus y. Then u shall be equal to ln t. So that means du dt shall be equal to 1 over t. So applying the chain rule there to get the du dx value, so the dx value is going to be the value that we get when you differentiate this value on the left hand side. So the final answer for that, we can actually see that du dx, so we know t represents xy, so du dx shall be equal to 1 over xy into bracket x dy dx plus y. So therefore we're going to substitute the value that we get from here after we differentiated this. Now we're going to have that value and we're going to put it back in our derivative. But obviously now when you differentiate this value on the right hand side also, it shall be equal to 8x. So now we have this value here being equal to 8x after we've differentiated. Alright, so now moving on to that, we can actually see that now we can easily cross multiply. So we can cross multiply both sides. So this x and y can multiply the 8x, and then we'll have 8x squared y. Then now we can actually see that we can separate the values that have dy dx from those that don't. So now we have x dy dx shall be equal to 8x squared y minus y. So now dy dx shall be equal to 8x squared y minus y over x, and that is the answer they wanted. Right, so moving on to the next question, we're being told that if x squared tan y plus y power 10 sec x is equal to 2x, find dy dx. Alright, so this is a unique example, and that is because we actually have product rule here and right there. So in this example, we actually have to be very careful. So now when you deal with this pair here, we can actually see you can let u be equal to x squared. So that means du dx shall be equal to 2x. And you can let v be tan y. So dv dx shall be equal to sec squared y. But because we're dealing with a y value here as the variable, we're going to multiply to it a dy dx. Then also right here, we're going to let the u, for this pair, we're going to let the u be equal to y power 10. So that means our dv dy, our dv dx, our du, actually we're going to let the u, so we're going to let u be equal to y power 10. So du dx shall be equal to 10 y power 9. Then we're going to let v to represent sec x. So dv dx shall be equal to, I believe the answer is sec x tan x. So when we apply the product rule there, we can actually say the product rule here, we're going to have the u, for this pair here, u is x squared, and then dv dx is sec squared y dy dx plus, and then the v value is tan y, and then times the value of du dx is 2x, and that's what we have for this pair. Then for this pair, we can actually see that u is y power 10, and then dv dx is sec x tan x, just as I've said, plus we have v is sec x, and then du dx is 10 y power 9 dx. Oh, sorry, so actually I forgot this here, because we're actually differentiating a y, a value with y, so 10y power 9 will actually multiply with dy dx. I'd actually just forgotten that, but that is important. So we're multiplying that to a dy dx, all being equal to 2, because when you differentiate 2x, it shall actually be equal to 2. So now when open brackets and simplify, this is actually what we end up having. So now we're going to separate the values that have dy dx from those that don't, and this is what we end up having. So therefore dy dx shall be equal to 2 minus 2x tan y minus y power 10 sec x tan x divided by x squared sec squared y plus 10y power 9 sec x, and that is the answer they wanted. Alright, so moving on to question number 6, we're being told that if e power 2x plus 3y is equal to x squared minus ln bracket x y cubed, find dy dx. So now we can actually say that this is what we have at the moment. So now when we deal with different values, so when we actually differentiate this side here with our knowledge of trigonometry, we know that when we differentiate these values here, so remember that when we're dealing with an e, we differentiate the values at the top. So we know that we'll end up having 2 plus 3. Remember, when you differentiate 3y, you are left with 3. But remember, because you're dealing with the y, you multiply to it a dy dx. So the answer you get from there, you multiply to the left-hand side of the e. And that's what we have right here. Times e with the same powers that it actually had originally. And then you can actually say that x squared shall become 2x minus. Now remember that when we actually apply chain rule to this, as we've done in some of the examples before, when you apply the chain rule, you actually end up having this as the answer. So now this is actually what you end up having right there. So we open the brackets, so this value multiplies the values in the brackets, and that's what we have right there. And then right here, we're also going to open brackets. Now this minus sign will affect the different values. But now, as you can see, the x is cancelled and the y is also reduced, and we're left with 3 over y dy dx. Then here we are left with 1 over x, and then this minus sign affects the signs in the middle of the brackets. So when we simplify this, this is actually what we end up having. So now when we separate the terms, when we factorize out dy dx on the left hand side, we end up having that. Then the values on the right hand side, we simplifying the LCM, and the LCM shall be equal to x, and that's actually what we end up having. So that's how they look when they're rearranged. So making dy dx the subject. Actually, before we do that, let's find the LCM here. So the LCM is y, and this is what we end up having. So now basically I believe we can just cross multiply. So when you cross multiply, this is what we have. So therefore dy dx shall be equal to y into bracket 2x squared minus 1 minus 2x e 2x plus 3y over x into bracket 3y e 2x plus 3y plus 3, and that is the answer they wanted. So therefore try out this exercise to get better. So differentiate with respect to y with respect to x the following functions. So this is it, and that's the answer it's expected of you, and that is it. So this is part C, part D, and that's going to be part E, and then lastly this is part F. So try this out and compare your answers to what I have on the side of each one, so that you get better at implicit functions. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.